Welcome to Monochemistry. Today we're going to learn about how to predict the pH of salts. Before we do that, we have to go over what the definition of a salt is. When most people think of a salt, they think of sodium chloride, which is really just one type of salt that we have in chemistry. It's table salt, and it's what everybody calls salt. It's the common name for sodium chloride. But really, there are different types of salts. And these salts are essentially all of the ionic substances that are not acids and bases. Or, if you prefer, they are the substances produced during a neutralization reaction, such as the one I have drawn at the bottom of the screen here. Notice that in this reaction I'm reacting an acid with a base. And of course, when you react an acid with a base, you get water and salt. In this case, it just so happens that I'm creating sodium chloride. Now, I want you to pay attention to this. Notice, the cation of the base forms the cation of the salt, and the anion of the acid forms the anion of the salt, and that will always be the case. Okay, so the salt is made up of the cation of the base and the anion of the acid. Make sure you keep that in mind, because that's going to become important. This table here is very important also. It's a version from your textbook on page 693. If you're in AP Chemistry, that is. Now, take a look at it, copy it down, and we're going to move on to the next. To start, we're going to look at neutral salts. These are any salts that have been formed from a strong acid and a strong base. Remember that the cation came from a base. Now, what base would be made up or would have K in it? It would be this one. And that, I think you'll remember, is a strong base. And on the other side, what acid would that come from? Well, how do I figure that out? I just use the I, and remember that would be a negative, and I add an H to it. So it came from HI, and as you recall, both of these are strong. And because both of the parts of the salt came from strong acid and strong base, the pH is going to be equal to, approximately equal to, 7. And that's true of all salts that come from strong bases and strong acids. Let's move on. What if the salt is composed up of a mixture of weak acids and bases? Then we start to run into scenarios where the salts themselves can actually take on acidic or basic properties. So let's take a look at this one and see what we can come up with. Recall your Bronsted-Lowry definitions here. Okay, so if this part came from an acid, that means this part is the conjugate base. So in order to become an acid again, you would add an H. So this would be HCl. Okay? Over here, this part is from the base. Is from the base, so it would have originally been NH3. Now look at these two things. This one came from a weak base. NH3 is a weak base. This one is a strong acid. You have a strong acid combined with a weak base. Therefore, the pH is going to be acidic, which makes the pH less than 7. Okay? So again, you look at what the salt is composed of. You look at what the salt's composed of, and once you know what it's composed of, or where the salt came from rather, then you can determine what the pH is. Let's take a look at a basic salt. I'm going to try and use a couple of different better colors this time because that blue I didn't like. Okay, so sodium. Sodium came from a base. How do I know that? Because all of the cations, or the positively charged parts of salts, came from a base, just like I said at the beginning of the lesson. So this one had to come from NaOH. Now how do I know it's not losing a hydrogen? Well, look at it. Does it have a hydrogen? No, so it must have come from NaOH. And that's a strong base. F, on the other hand, came from, if you treat it as a Bronsted-Lowry base, in this case, came from HF. And HF is weak. Okay, so NaOH is strong, HF is weak. You mix those two together, the salt that you get is obviously going to have a pH of greater than 7. Okay, try a few of them, see where they came from, and see if you can predict this. Use the ones in the chart if you want, that I gave you on the first slide. Let's go on to the next one though. Okay, for this one we need to look at. We have to use our Kas and Kbs to determine the pH of this salt. Now why? Well, here's why. This part is actually the negative part, by the way. And this is actually the positive part. Okay, so this part came from acetic acid, which is CH3COOH. And this one came from NH3. So that's what was reacted. This was what was reacted to get this salt, right? Both of these are weak. So how then do we determine the pH of the salt? Is it going to be neutral just because they're both weak? Or do I have to look at something else? I think you know the answer because I put it up here. The answer is you have to look at something else. So what we need to do right now, and I'm going to get you to look these up in your textbook, wherever you can, you need to know the Ka and the Kb. So go ahead and look that up. Okay, now that we've looked them up, I think what you've noticed is that the Ka for this is equal to the Kb for this, which is equal to 1.8 times 10 to the negative 5. They're both the same. So guess what? Because the Ka and the Kb are equal, the pH of this salt is going to be equal to 7. Okay, but in general, the Ka is greater than the Kb, the pH is going to be acidic, or less than 7. If the Kb is greater than the Ka, then the pH of the salt is going to be basic, or greater than 7. Let's move on. Alright, this is the last part of the chart. And this is important. Just take a look at this. Small, highly charged cations this would be Fe3+, with an anion from a strong acid. Okay, so here's our anion. That would have come from HCl. Here's our anion for this one. That would have come from nitric acid, HNO3, both strong acids, are acidic. Okay, so small, highly charged cations, if they're with an anion from a strong acid, are acidic. Now here's the question. Why? Why are they acidic? Watch what happens when I add these two things together. So Al3+ added to water, it's going to split water, or hydrolyze it. Hydrolysis, splitting water. Hydrolysis, splitting water. It's going to hydrolyze it. Al3+ is going to basically make water turn into this. And any time water gets split and forms an H+, guess what? The pH of the salt, or the surrounding solution, is going to be acidic. Now go back and look at the other ones that we did. Look at ammonium. Look at the NaF. Those anions and cations, respectively, are going to split water. Sometimes they're going to split water and give an H+, sometimes they're going to split water and give an OH-. Whichever one they do is going to determine the pH of the solution. And that, in a nutshell, is how you determine the pH of salts. Bring your questions to class.